Okay, we have a MacBook Pro. It's 16 inches, and then it says that it's a board level. So, which in other words, they're trying to say that the machine it's no power, most likely. This has already been assessed. And then they came to the conclusion that that issue it's board level. So this is one of the ways you can identify or differentiate between a 15 inches form factor and a 16 inches is the escape key separated from the touch bar and the power button or the touch ID. If this was a 15 inches, the touch bar, the escape key, and the touch ID will be on the same line. But then because it's 16 inches, you see you have an actual physical separation between them. Okay, so that's about that. For devices that do not turn on, we don't connect charger directly. We first want to see what's the state of the device by opening it up. So that's what we are going to do now. This is an A2141. This is the first 16 inches that Apple made, and it's Intel. The refreshed of this, there was only one of this that Apple made. When Apple decided to refresh it, they replaced it with a 16 inches M1, and that was in 2021. So this was sold in 2020, 2019, 2020, and in 2021 they replaced it with an M1 16 inches. Okay, so screws are out. If this is the first time you're doing this, you want to make sure that you take note of the screws. Let's do a bit of a visual inspection. The device looks fairly clean. The 16 inches are they commonly have issues on the 2.5 volt line, which is SSD rail. And when that happens, it then translates into a short on your PP bus rail because you have a current sensing resistor that connects your PP bus rail to the 2.5 volt line for the NAND. So, usually when that happens, the SSD voltage regulator IC blows up, it burns out, and then it sends a 12.6 volt onto a line that's supposed to receive 2.5 volt. I'm hoping that that's not going to be the case here, because if that's the case, it means we have to replace the SSDs. So the first thing we're going to do is to locate our battery, which is here, and then this follows the same pattern of the dual battery communication system for Apple designs. You have a cable and the main power line. So you have the battery cable. By disconnecting the battery cable, I've effectively disconnect the battery power from the main board. But then there's a secondary main power line, which is a high voltage line, and then this is just a data line. If this is a Chinese battery, or if you're not sure, it's better to remove the main battery power line. But if from what you can see here, this looks like 100% Apple battery. So disconnecting the cable will suffice. Okay, so with that, the next thing we're going to do is we want to see if we have a short. So we're going to check to see if we have a short on our PP bus. If not, we are then going to see if we have a short on the right side 2.5 volt line and the left side 2.5 volt. So on the 16 inches, you have two separate 2.5 volts. You have one on the right and then one on the left. Sometimes you may have a problem on the right and then the left is fine. Sometimes you may have a problem on the left and then the right is fine. So the first thing we're going to do is we're going to check to see if we have a short on our PP bus using the fuses. This guy here, this and that. These are fuses. These are PP bus fuses. We're going to use that. And then after, if we don't have a short there, we're now going to check these inductors here are sitting on the 2.5 volt line. We're going to check this inductor to see if we have a short. If we don't have a short, we're now going to check this side of the board to see if we have a short on the 2.5 volt line, because these two capacitors, they are also sitting on the 2.5 volt line. So those are the common these are the first line of troubleshooting that we are going to do. So battery is disconnected. We have our multimeter into continuity mode. And by the way, this sign here, that's your continuity. So you might not see it there, but So with this multimeter, if I do this, so that sign, that's a continuity. Okay. So I use this one because it's quite loud, and I say, you see, I set it to continuity. Okay, so we have our black probe to ground and our red probe. We want to see what we have on our fuse. Alhamdulillah, we don't have a short on our PV bus. That is good. The next thing we want to do is we want to check on the right hand side to see if I have a short on our 2.5 volt line. That's good. We don't have a short on 2.5 volt line. Two things we are looking out for. Number one is to see if it beeps. It doesn't beep. And number two is to see if we have a low reading on the multimeter. And then, so the next one is we are now going to check this side of the board. And we don't have a short there. Okay, that's good. So it means we don't have a short in, so we can connect power to it to see what is it that we have. So let's connect power to it to see if the device is going to start. Without the battery being connected, without the battery cable being connected, the device will still start, provided you're using the 96 watts charger. 96 watts. So let's see, do we have, let's see if we have a PP bus voltage. So we have charger connected. We switch our multimeter to voltage mode. See when it says V, so voltage mode. So left probe on ground, and then our red probe. We want to see on our PP bus, do we have 12.6? We have 3 point something. So most likely we have 5 volt on the PPDCIN line. So let's check here. Let's see, what do we have? Do we have 5 volt or 20 volt? What's that? We are getting, okay, we actually getting a flux. So it's 5 volt and fluctuating actually. And then the other one, same thing. So, okay, so what we're going to do, because of what we're getting now, it will be safe for us to actually take the board out. Do you understand? So we see that now that we see that we are getting less than what is required, which is for this machine we're supposed to get 20 volt for PPDCIN volt, a PPDCIN line in order for the machine to operate. That is the starting voltage for your PPDCIN. If it does not boost to 20 volt, your USB-C charger is able to put out ranges of voltages starting from 5 volt now, and then all the way to all the way to what is set for this machine, which is about 20 volt and something. Now the device, we are getting less than 5 volt, and also it's fluctuating. So what we want to do now is, it would mean that we want to, this is not the same as the M series where we want to concern ourselves with inside. We are actually going to concern ourselves with the actual control, the negotiation between the charger itself and the companies that are responsible to negotiate for 20 volt. Do you understand? So let's quickly take the board out, and then we are going to concern ourselves with the CD32s. The CD32s are, so we have four ports here. We have 1, 2, and then on the other side we have 3, 4. Now those 4 ports are going to be controlled by a CD32. For the 16 inches, this is going to be CD3217. For the for 15 inches and below, it's going to be CD3215. And by the way, so you see something like that, you need to take the camera closer, because if you zoom it out, you get it. Okay. So you have the CD3215, CD3217, and CD3218 for newer devices. Now, but these are CD3217. The footprints are not the same with CD3215. And also there are also different revisions of the CD3215. So sometimes you may have one not working on the other, but that's something that's in cases when you're actually ordering for the new one. Okay, that's that about that. So what we're going to do, because we are getting the voltage is fluctuating, we are going to now take the board out. We're going to start with T4 screws. If this is the first time you're doing this, you want to take note of what is what. So I'm just going to place this here for you, just to, so that this is easy to identify, correct? The ones that goes the hinge cover, these are unique. You can easily, the ones that might throw you off will be the one here. Okay, so this is also unique in size. You can easily tell. So this should be the one there, here and here should be the same. You see them? Okay, so you should get 6 of those. So all of those screws are going to be same size and same type. Now this and this will be the same. So this and this will be the same. So you don't have to worry about which is which, as long as those are concerned. I'll put that one side. What else do we need? Okay, then that's unique. You see, it's quite long. There are 2 of that, and then one on the other side as well. So that is that. What else is left? I think now we left with a T8. Okay, we see need this. Okay, so this is also easy to identify. It's longer than what we took out from here. Yes. And in terms of size, these are very small. So, so just gonna put them also that side. So that also help you know which is which. And then we now need our T5. So this, the ones I'm taking out now, they are all of the same size. You don't have to worry. I wish the one that is different is going to be, that's also T4. Yeah. And now this and this, they are going to be exactly the same thing, correct? See, they're different from, you see them? Yeah. Yeah, so those 2. The rest are of the same set. And then obviously this is unique. Now this and that, they will share the same, is basically the same. 1, 2, 3 are going to be the same, and it's a T4 head. Exactly the same. Okay, so and then my T8 or 10, depending on what you have, and this is unique because of the screw head. Okay, and that's it. So now we want to take out our cables in order for the board to go out. And also, if this is the first time you're doing this, you want to take, I mean, so do I need to walk you through the cables? You know what that one is, yeah? And this one, you know that. And then this one, this one. What is there? And then this one, and this one. Okay. This. Yeah. And that. Okay. Remember this cable, correct? This one is for backlight. And then that will be for the flex gate. Yeah, that's the breaking of it over time is what is described as a flex gate issue. Yeah, but the 16 inches usually do not have flex gate issues. It's common among the 13 inches, 2016, 2017, and the 15 inches, 2016 to 2017. So while you're taking the board out, you want to make sure you take all of your cables out of the way. Okay. Something that did you mention what this cable is? This one. What is this? Yeah, and this one? This is actually no. This is your mic. This is your jack. Yeah, but you didn't ask yourself about the keyboard backlight, the keyboard backlight cable. This is the keyboard cable. What about the keyboard backlight cable? You know what this is, yeah? And this one. It's a touch bar. Remember, one is going to be for main image, and then one is for touch. You remember? Okay, this. Say that again. The escape button. No, 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 no. 16 inches. Yeah. So for the touch bar, you have two connections on J55, 11, 51, 10. You see where it says display. So to show you those whatever you have on, and then the other one is to allow you to actually to 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 instruct it. So this is going to be for touch. No, wait, no, it's not that one. That's angle sensor. Yeah. So this is the one for touch. Yeah. You see it? So so this one is for this is going to be for your touch, and that's gonna be for one for display. And then the other one, one for J J8400, the keyboard backlight. You understand? You know, for all other machines, you sometimes you find it close to the keyboard, correct? But in this case, it's not. So it's this one. Yeah, but this is the keyboard itself. No, 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 no. This is the keyboard. This is a keyboard connector. Yeah, and the keyboard backlight connector is this one here. Oh, yeah. Oh, okay. Yeah, but then if this becomes a keyboard backlight, the question would then be, what about the keyboard connector itself? Okay, so that's that. And this is good to know what is what, especially when you put a device together and then the client comes back and say my keyboard has no aha. Now, another thing I want to mention. So the keyboard backlight for those devices that have an actual regulation of the keyboard on the actual keyboard regulation on the keyboard, there is something that is referred to so they have the ambient sensing. So what that means is this. So if you have light here and the settings is set to auto, when you try to increase the brightness, I'm gonna bring your machine and show you. So sometimes you may get a client might tell you, oh, you've worked on my machine, now my keyboard backlight is not working. So the keyboard backlight, so here you see I'm able to increase it and then I decrease it, correct? Okay, so let's come to your settings. Turn keyboard backlight off after. So keyboard brightness, adjust keyboard brightness in low light. Uh, so let's see, keyboard navigation, no, not that one. Turn keyboard, okay, so that's fine. That's turn keyboard backlight off after inactivity. So let me see, I'm not sure if you can, so you see, I'm not sure if you can capture that. So if this is set to, if it's set to auto, which means it will regulate according to, if you're in a dark environment, the keyboard backlight comes on. But if you're in a, if the environment is it's bright, then the keyboard backlight will not work. Now, if the environment is light and then you try to increase the keyboard backlight, you might get a no entry sign. You see this, what will come out will just be this in the middle only. When that comes on, it means that you are in an environment that is lit. So what you need to do is you need to manually show the machine that is dark. Then you can cover the light. So you see the webcam cut out. You see the here, the ambient sensor. You see the same area for your eyesight camera. You see that there is, when you cover it, because it uses that same area for your sense for the area sense. When you cover it, then the machine will assume that it is dark. Then this will come on, and when you try to increase it, then it will increase. Okay. Anyway, that's that. In case you have an issue where your client be like, "Oh, my keyboard backlight is not working," and I try to increase it, it gives you a no entry sign. Just tell them to just cover the screen and then try to increase it. Okay, so this is out. Our focus is going to be on the CD3217. So we have four CD. We should have four here because we have four ports. So we have two here for this, and then we should have two on this other side. So one, two, and 1, 2. So what we saw was when we try to so PPDCIN was 5 volt and dropping. So we are going to try and then check that out again. But before we do so, let's quickly dust the board. Okay, let's try again. See, this doesn't have the MagSafe 3 port. It's so if this was an M1, it will have the MagSafe 3 port. Okay, so let's start with the first port. See, what do we have on PP bus? We were getting less than 12.6. Okay, so yeah, that's fine. Now let's see, what do we have? Okay, so it's trying and then it goes down. So let's try the second port. Same thing. It's actually lower, correct? Let's see the other side. Same thing, yeah? Okay, let's check the other one. Okay, so we tend to have the same thing. So what we want to start to do is to check for a short around CD3217. Now, because they all behave exactly the same way, we might not necessarily have an issue with the CD3217 themselves because they all behave in the same way. So, but nonetheless, let's start. So we have our black probe on ground and our red probe. That's a short. We're not supposed to get a beep there. On the other side, because there's a capacitor, so we're supposed to have a beep one side or not on both sides. And so that's a short. We're going to find out what that is. Let's see that. That's also a short. Now, okay, so I'm just going to show you some. So that you have a short, yes, and then here you have a short. Now, if we go to the other side, it should be expecting to have the same thing. Hmm? So we have something on that line that is shorted to ground, that is making its way to ground, which is why the whole set of CD3217s are behaving the same way. So now let's see what is that? What line is that? So the line that's shorted is this one, correct? So what line is that? It's this line here. So it's PP3V3 underscore G3 hot, which is RTC. Now that is a clock line. This is the line that is shorted. So that line, something on that line is shorted, which is why the whole C3217s are behaving the same way. Now there are two ways. This line is not unique to the CD3217. However, the LDOs are unique to the CD3217. What I'm trying to say is, so you see this PP3V3 underscore G3RDC is not unique for the U3200, correct? So if I have a problem on this line, I'm not going to directly be looking at U3200, even though U3200 might be a problem. Now, if one of the U3200 is my problem, I will be able to pick that up from the LDO because the LDO are directly connected to the CD32. CD3217s. Do you understand? Unlike this one, there are multi connections. There are multi layers to this. You know, this is connected to. This is not directly from U3200. This is being generated from somewhere else. But if I want to now, one of the ways I can tell if my CD3215 has failed at that point is by checking to see if I have any CD3217 that will beep at its LDO, not here. So this, it can be anywhere on the board. But if I get a beep on the LDO, then that is unique to either the capacitor or the CD3217. So let's check on the CD3217s across. Let's see. So we know that we have a short on our RTC line, which is this one. That's fine. Now let's check. Let's check for that. Or do we have a short on that? No. Do we have a short on that? No. That's fine. And here we don't have a short. We don't have a short. So we are not going to blame either of this. Now let's move to the other side. Let's see. We know we had a short here. That's the RTC line. What about this? We don't. And this, we don't. This, we know we had a short. That's fine. That. Now it clears our CDs because so easily, if one of the CDs was the problem, it should reflect in its LDO. And by the way, sometimes it might not beep, but we'll have a very low reading. So let's see. Okay, so yeah, that's fine. So now we want to now look around our ROTC line to see what could have been, what could be the problem. So ROTC line is also, by the way, the ROTC line is it's powered by our PP bus. We know PP bus is not present. RTC line is going to be required for our PP3 before the PP bus voltage is going to be required for our RTC to be generated. But in this case, we're not talking about its generation. We're talking about the line itself being shorted to ground. So we want to find out where that line, what is causing it to short to ground. Let's go to where it's being generated. So that is being generated from these guys here. Here. This is where it's been generated, and it's been generated by U6960. So let's look around this section here. So one of the ways we can also isolate it to see if the problem is coming from this side of the board, the creation side, or the machine side, is by removing these two. So those two are going to be like the bridge. If I click on this side, you see it only shows me, so it shows me the generation side. This is where it's been generated from. After it's been generated, then it comes through these two resistors and then feed the machine. You see all of these other points now. This is where it gets connected. So what we want to do now is we want to remove these two resistors, which will now tell us if we get a short here, it means the problem is on this side, not on the creation side. If we get a short this side, it means not okay. So, and that is this guy here, this two guy here. So one thing we can also do before we remove that, we can look across the board to see if there is any component that looks funny on that line, correct? So we first of all, we click on the line, and then it will show us all of the components that are connected to the RTC line. So let's look at that. So we see that doesn't look funny. We don't see anything that looks funny there. And what about on our, we also have it on the lead sensor. We don't have any type of corrosion on the lead sensor connector, so that is fine. And then so we also want to check here, this is a resistor. No, we don't really have to worry about that. There's a sys detect. And then here, do we have anything that looks suspicious there? And we don't. Okay, so what about the others? Okay, before that, yeah, and this side as well, nothing looks suspicious. What about the other side of the board? Let's check the other side of the board. The other side of the board. So let's check this side first. So let's see, do we have anything here that looks, no? What is this? Is that an RTC line? Looks a little coded. Let's see if it's on the RTC line. No. PP3V3. Yeah, that cap there. So PP3V3 underscore RTC becomes PP3V3 underscore through R5680. So this is more like a bridge, yeah? So we see a cap. This cap here doesn't look so good. This one here, C5102. This guy here, this one, C5102, doesn't look so good there. So whatever is going to be here is going to be equal to what you have there. Hmm? So what we are going to do is we are just going to do, just easily remove it, like that. Okay, let's check again. We're going to come back to it. Black probe on ground, red probe on okay, we still have a short. Let's check again. Okay, we still have a short. And then on the other side, yeah, we definitely still have a short. Okay, let's continue. So but then we know that that cap, even though it's still fine now, we're most likely that was going to be a problem. Okay, so whatever is here is going to be equal to, so okay, that's fine. And this guy here, it's not really a problem, just a pad. We are going to find out what that is in case we might have a broken part there. So let's just see. Okay, what else? What else? And then on this side here, do we have anything that looks, no? And this side, do you have anything that side? No. What about this side? No, no, nothing there. And this side here, let's check this side here. Okay, so we don't see anything that stands out. I want to look closer. Okay, nothing stand out. So the next thing we are going to do is we are going to remove those resistors to at least to understand if our, to narrow down where the issue itself is coming from. And we also know that we did also confirm that the PP bus, we don't have a short on our PP bus line, correct? Okay, we don't have a short. Okay, let's remove those resistors. Okay, so now that those resistors are out, what we want to do is that we want to check which side of the board the short is present. So we want to see, do we have it on this side? Okay, it's not on the creation side. So this is the creation side. It's not on this side. So our problem is on this side. Now we want to find out. So from here now, so we can choose to, so that is now the system side, not the creation side. The system side. So we can choose to, uh, let me see, we can inject voltage. So what we are looking at, so here, that is, wait, SSD. Yeah, but let's see, what do we have there? So which is this guy here. We have PP3 that fits it. No, that doesn't look to be a problem. Okay, let's continue looking. And this guy here doesn't look to be a problem. We might have to inject voltage, but before we do that, let's just be sure that nothing nothing stands out. Okay, we don't really see anything that stands out. Let's look at this pad before we forget. This pad there. Okay, let's not worry about that. That's fine for now. Hmm. The board seems generally very clean. We don't see any capacitor that is looking suspicious. Okay, so are we gonna inject voltage, or let's check around the CD3217 again. Let's see if any of it gives us a low reading. It's, it seems to be fine at least. That's the RTC line. Okay, nothing around the CDs that shows okay, so let's do one inspection one last time before we decide on injecting voltage. Hmm. Okay, so we may have to just we may have to inject voltage after all. So we're going to inject voltage, but I just didn't like to inject voltage. Let me see. Uh, hmm. Nothing on the board stands out, but we have a short on our RTC line. And is on the system side, not on the creation side. Hmm. Okay, let's inject voltage. So the idea is whatever component on the board that it's connected to ground will become warm. So that's the whole idea. Uh, I don't generally like to use don't generally like to inject voltage. Mm. Okay, so we are going to inject voltage. So we are going to inject voltage on the board, and then we now look around all of the sections, or all of where you have all of where you have that signal. You have to look across to see if anything is getting warm, which is yeah. And because it's the voltage is quite low, it's just 3 volts, so you have to be careful not to. Okay. I know my boy messed this up. Gosh. Uh, okay. And I'm going to slightly increase the voltage. Okay, let's see. Anything getting warm on the board? So if anything is getting warm on the board. Okay, I think something's getting warm on this side. This side here. Yeah, something seemed to be getting warm on this side. Yeah, something is getting warm on this side. Yeah, something is getting warm on this side. Yes, something is definitely getting warm on this side. Hmm. Yeah, something is getting warm on this side. So what I'm going to do is we're going to remove the capacitors this side. Something is getting warm on that side. So let's remove the capacitors that are sitting on. Okay, so let's remove so we know, let's remove the capacitors that are sitting on the RTC line here. So if not, yeah, so let's remove this guy and this guy because these two are sitting on the RTC line. So let's remove those because we see something is getting warm on that side. Okay, so let's check any of those capacitors. If any of it beeps, then that's good because that means that's our problem. Doesn't beep. Let's check again. Doesn't beep on this one. That's our problem. So this guy is our problem. Let's check that again. Okay, now let's check the line. Let's see. Do we now see have a short on the line? Alhamdulillah, the short is gone. You see that? So now the short is gone. Okay, that's good. So that's our problem. Let's quickly put that back and alhamdulillah. Let's get another board to replace the cap. You're sure you're not too far away, no? Okay. And the other cap that you took out at the time, let's put that back as well. Remember the one here. Though it wasn't our problem, but it probably was gonna be a problem in future because it wasn't looking good. Okay. And then the resistors have to go back now. Do you understand what we did here? No, not capacitor, whatever component. Yeah, yeah, that got warm. That will mean that that is so because what is happening is a component is connected straight to ground. So say for example, this is a capacitor. Yeah. Now this is a capacitor that has two ends, one and two. One side is connected to the main line, which is going to be the voltage line, and then you have an insulation here. There has to be a separation between, and then you have ground. So which means one and two are not going to be equal. If this fails, one and two will become equal, which means across all the board, the voltage that gets here will be going through this capacitor to ground. Because because voltage is going through to ground, it's going to react to the voltage, which then means that it becomes warm. You understand? So that's the whole idea. Yes, 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 yes. Oh yeah, we should probably test before we clean, but I think that that should be the only problem. Yeah. Sometimes you have multiple issues, but this looks really clean and so we clean that and this side as well and here as well. So you see that? Yes, ground must beep. Yeah, ground must beep. Yeah, that's a capacitor because it has two ends, main and ground. So usually they say ground is a reference point. So whatever when you have one probe on ground and another probe on a component, if it beep, it means that component has a path to ground. It has a connection to ground. Yeah. So you now want to check to see on that you now want to go to the component and check what type of component is it. Is it supposed to beep, or is it supposed to have a path to ground? So that's how you figure out which component is shorted and which is okay. So let's test. We know initially we will get a fluctuating voltage, and then PV bus was obviously not even present. So now let's see if we have a PV bus voltage. The short was obviously we had this here 3.3 RTC. This was where the problem was. Now it's present. PP bus. What do we have on PP bus? 12.6. That was not the case before. And here we were getting a fluctuating voltage. What do we have now? OL, because we have the voltage that we're measuring, it's slightly higher than 20 volt. So if we set it to 200, for example, we should now have a 20 volt, correct? So because it's 20, because it's slightly above 20 volt, and we set it to 20. So if we send it to 20 as it is, yeah, and then we measure, what we will get is it will give you the value and then quickly flip. You saw? Yeah. So now yeah, because it gave the value and then it kept increasing until it became 20 point something volt. Okay, that's fine. So this is most likely a fully working board. We're not just going to confirm that indeed we now have a working machine, and we'll leave the rest to Shahid to do his magic. So and also he's going to dust this. Should we dust it for you now? Okay, so just dust it so that you can. Oh yeah, because you don't want to remove the board for the second time. I don't be lazy. Okay, so when you're dusting it off, you obviously be careful because of don't want to rip out any of the cables, especially on this angle here. Hmm? If it means having to cover it yourself, at least you know that it's safe, but still be aware of it. Yeah. This when it goes in, you don't have to take it out to just continue from there. Okay, so let's put our board in. Something is okay. So we're only going to connect the cables that we require for the testing. So we're going to connect the screen, the fans, one of the speaker. That's about it. And this is jack. Trackpad. Yeah, let's put a trackpad at least just to first to get the sense of feedback. A trackpad. So you see, we're not connecting the battery, but that's we have to be using an 86 or higher. So 86, 86. Oh, sorry, 96. Yeah, 96, not 86. Yeah, 96. Yeah. Okay, so I connect to my charger. See if I get fine response. So on this one, once the fan respond, that's it's gonna spin once and then stop, which is good because that's when the machine is actually starting. So I like to see the fan spin, and see, and there you go. Alhamdulillah. Sometimes if the power is not enough, it might show you the battery sign to show you low battery. You understand? Then you know just need to connect your battery. Okay, as you guys can see, that it's completed repair. We had a short on our RTC line, and then remember again, the behavior we had, because we had the same behavior across the 4 ports, we couldn't just say no, the problem is. But then again, we said if one of them was an issue, then we have to look for something that is directly connected to them, which is the LDO lines. Okay, so that's about this one. This is ready, and Shahid will take it off from there. Now the other one